In this video, I'm going to show you how you can use a scientific calculator to determine the equation of the least squares regression line. That is, y is equals to a plus bx. Let me brief you in on our problem statement. A mathematics teacher wants to make an unbiased prediction of a grade 11 learner's final marks. She uses the SBA mark and knows the final mark. The results are as follows. So this is the x values and this is the y. We're using the SBA mark to predict the final mark. In question 1.1, we're supposed to draw a scatter plot for the data, but we're just going to go ahead and start with 1.2. In 1.2, we're supposed to calculate the correlation coefficient for the data, that is R. Let me show you how we can do that with a calculator. You want to press mode or setup, and then you want to go to start. Here in this calculator, it's option number 3. So I'm going to press 3. After pressing 3, I'm going to go to the equation for the least squares regression line. That is a plus bx. You can see here that it is option number 2. On a different calculator, it might be a different option, maybe option number 3, but the steps are identical. Now I just have to punch in my x values. As you can see, the first x values I have 42, followed by 35, 69, 62, 83, and 75. But then my x values are still carrying on. I have 48, 72, 57, 25, 65 and 68. You have to verify your entries at least 2 times, because if you entered a number incorrectly, then your answers are going to be incorrect. So now let's put in the y values. We have 51, 43, 76. You don't just put the y values randomly, you put it close to its x value, right? And 72. Let's go to the other column. We have 59, 85, 63, 35, 59, and 75. Yeah, there we go. We have our data inserted on our calculator. We're going to press equals to a couple of times, and we're going to press AC. After pressing AC, you press Shift and 1. You can see above 1 that it says stat or distribution there. So we're going to press Shift and then press 1. We are interested in the least regression line. So we're going to press the option that says REG, just short for regression. So here it is option 5. In the calculator, it might be different, but it doesn't matter. So I'm going to press 5. After pressing 5, you're going to see that I have A, B, R, X, and Y. So I'm going to press number 3 because I want to find the correlation coefficient. I get 0.94. So the value of R is 0.94. And then now I can move to 1.3. The question is saying, is the SBA mark a reliable predictor of the final mark? Provide a reason for your answer. Obviously, it is a reliable predictor of the final mark because we can see that we have a very high correlation of 0.94. Let's move to the next question, 1.4. Determine the equation of the least squares regression line. Like I've said, we have y being equals to a plus bx. So we just need to find the value of a and the value of b using our calculator. So let's go ahead and do that. Again, we're going to press AC, Shift, and 1. We're going to go to number 5, regression. And now we're looking for A. So we're going to press 1. And A is equals to, let me just write that down. A is equals to 14.49. That is the value of A. Now we just need the value of B, and we have our equation for the regression line. AC, Shift, 1, and 5 regression. I press 2 and we have our value of b. B is equals to 0.86 if we round it off to 2 decimal places. So the equation y is equals to 14.49 plus 0.86x. That is the answer to 1.4. Let's look at 1.5. Predict Toby's final mark if his SBA mark was 66%. So we just need to substitute 66 into our equation. We're going to have y being equals to 14.49 plus 0.86 multiplied by 66. Let me just go ahead and do that using my calculator. I'm getting 71.25. So that will most likely be Toby's final mark if his SBA mark is 66%. This set of data has a mean of 7. There's one interesting thing about this data. We have a variable y. Let's look at the first question, 2.1.1. We are given the mean and the question is saying that we must find the value of y. So we can easily say that x bar is equals to the sum of all the data points divided by the number of the data points. So that will give us 3 plus 4 plus 4 plus 4 again plus 6 plus 10 plus 12 plus 12 plus y divided by the number of data points. How many data points do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we are dividing by 9. But we know the mean. The mean is 7. So we have 7 being equals to. Now we need to add all those constants, 3 plus 4 plus 4 up until the last term. If we do that, we're going to get 55 plus y divided by 9. We can go ahead and cross multiply. 7 multiplied by 7, that is 49, plus 7, 56, plus 7, 63. So we have 63 being equals to 55 plus y. It will be easy to see now that y is equals to 8. Let's go ahead and do 2.1.2. We're looking for the median of this set of data points. So let me just uncover our data points. In order for us to find the median, we need to arrange our data from the smallest to the highest. So if we do that, we're going to have 3 and then 4, 4, 4. After that, we have 6. We know that y is 8. So y is here between 6 and 10. And then we have 12, 12. The median is the data point in the middle of our data set when we have arranged it from the lowest to the highest. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Our median should be the 5th term. So that is 6. We can conclude here and say that the median is equals to 6. On the left of 6, we have 4 numbers, and on the right of 6, we have 4 numbers. So 6 is our median. We actually do have a formula for finding the position of the median. We can say that the median is equals to n plus 1 divided by 2. In our case, n is 9. We have 9 terms. So that is 9 plus 1 divided by 2, which is equals to 5. So our median, if we have 9 data points, will be on the 5th position. That is how you can find the position of the median if you have a completely different data set. 2.2.1, 2 additional numbers, 7 minus n, and 7 plus n are added to the data set. Calculate the mean of these 11 numbers. So a lot of people will probably think that this question is difficult, but it is not. These variables are going to cancel each other. We have minus n and plus n. So the fact that there is now another variable shouldn't be worrying. We can say that the mean is equals to. We know fully well that before introducing these 2 additional numbers, the sum was 63. So now we can just simply say that 63 plus 7 minus n plus 7 plus n divided by. Now we no longer have 9 terms, but we have 11. As you can see, minus n and plus n are going to cancel out. So the mean is just equals to 63 plus 7, 70, plus another 7, 77, divided by 11. That is just equals to 7. So our mean is 7. 2.2.2. Determine the standard deviation if the data points that are within one standard deviation of the mean lie in the interval x is between or equals to 11 and 3. This means that x bar plus standard deviation is equals to 11 and x bar minus standard deviation is equals to 3. That is the interval for one standard deviation of the mean. We can break it down like this. If we did say the 2 standard deviation of the mean, then we would just put a constant of 2 here. But then now we're just interested in 1 standard deviation of the mean. So we can use either equation. We're going to get to the same answer. Let's use the second one. So x bar, we know that it is 7. So we have 7 minus the standard deviation being equals to 3. It should be easy to see that the standard deviation is equals to 4. Can we find the equation of line BD if we are given the equation of line AC? Yes, we can. The equation of line AC is given by minus 1 divided by 2x plus 2. AC is perpendicular BD. That should tell us that the gradient of AC multiplied by the gradient of BD is equals to minus 1. So the gradient of BD will be equals to minus 1 divided by the gradient of AC. From the equation, we know that the gradient of AC is minus 1 divided by 2. So we divide in minus 1 by minus 1 divided by 2. The gradient of BD will be equals to 2. So now we know that for BD, y is equals to mx plus c, but the gradient is 2. So we have 2x plus c. All we need to do is substitute a point on our line BD and find the value of c. Just like that, we're going to have the equation of BD. We are given the coordinates of B, so let's go ahead and substitute that into our equation. We're going to have minus 7 being equals to 2 multiplied by minus 2 plus c. Minus 3 is equals to c. So now we can say that the equation of BD, we have 2x minus 3. Let's move to the following equation, 3.2. We are supposed to find the coordinates of E. E is the point where AC intersects BD. This is a very common type of question. You shouldn't be getting this wrong. What are we going to do in a case like this? We're going to equate the equation of BD and the equation of AC. If we do that, we're going to have 2x minus 3 being equals to minus a half divided by 2x plus 2. We're going to find the x value of E and substitute it into either the equation of AC or the equation of BD. So minus 1 divided by 2x, if we take that to the left-hand side, we're going to have 5 divided by 2x being equals to. Minus 3 to the right-hand side, we have 2 plus 3. So this is equals to 5. So x is equals to 5 multiplied by 2 divided by 5. X is equals to 2. So that is the x coordinate at E. Let's substitute 2 into 2x minus 3. If we do that, we're going to have y being equals to 2 multiplied by 2 minus 3. This is just equals to 1. So the coordinates of E, we have x being equals to 2 and y being equals to 1. That is 3.2. Let's do 3.3. If the ratio CE is to EA is equals to 1 is to 3, Determine the coordinates of A. That is not too difficult. Let's see what we can do. So E is to C and A is to E. We have 1 is to 3. So let's play around with these numbers. The coordinates of E, we have 2 and 1. We want to find the coordinates of A. X of C is 4 and X of E is how much? It is 2. What will be X of A? From X of C to X of E, we moved 2 units to the left. Our ratio is 1 is to 3. If we move 2 units to the left, then from X of E to X of A, we need to move 2 units to the left multiplied by 3. So we have 2 minus 6, which is minus 4. So that is how we can find the X value of A. And then now let's do the same for the Y values. The Y value of C is 0. What is the Y value of E? The Y value of E is 1. And our ratio is still 1 is to 3. Now we're looking for the Y value at A. From Y of C to Y of E, we moved 1 unit upwards. So from Y of E to Y of A, we're going to move 1 multiplied by 3. So that is 1 plus 3, which is equals to 4. So this is the Y coordinate of A. So the coordinates of A, we have minus 4 and positive 4. Our answer to 3.3. 3.4. Kite PQRS is obtained after the measurements of kite ABCD is enlarged by a scale factor 2. Calculate the area of kite PQRS. Right, let's calculate the area of kite ABCD first. And then we're going to multiply it by a factor of 2 to get the area of kite PQRS. So I'm going to erase all this. BC is equals to DC. That is a property of a kite. We don't have to think very hard about that. Is either you know it or you don't. And then AB is equals to AD. So what we can do, we can calculate the area of one triangle. After calculating the area of one triangle, we just multiply it by 2 to get the area of ABCD, because these two triangles ABC and ADC are equals to each other. The area of triangle ABC will be equals to half base. Our base is AC multiplied by our height, which is BE. We need to calculate the length of AC and the length of BE. What is the length of AC? AC will be equals to the square root of y2 minus y1 squared plus x2 minus x1 squared. Let's take our point A as our second point. Let's not forget, here we have coordinates minus 4 and 4. So x2 will be minus 4 and x1 will be 4. So we're going to have minus 4 squared plus y2. y2 is going to be 4 and y1 is 0. AC is equals to 4 square root of 5. Now let's calculate BE. BE will be equals to the square root of, we're looking at BE. Let's take E as our second point. So the coordinates of E, we have 2 and 1. Let's not forget. So y2 is 1 minus y1, which is minus 7. So we have plus 7 squared. Plus x2, x2 is 2, minus x1, minus 2. So we have 2 plus 2 squared. If you put that in your calculator, you're going to get 4 square root of 5. So the area of our triangle ABC is equals to a half multiplied by 4 square root of 5, square root of 5, not square root of 2, multiplied by 4 square root of 5. So now it's just a matter of putting that in your calculator, and we are getting 40. So the area of our kite A, B, C, D will be equals to 40 multiplied by 2, which is 80. And now the area of our kite PQRS will be equals to 80 multiplied by 4 and not 2. This is equals to 320 units squared. Determine the numerical value of m. We are given n, the center of the circle, and that's where we have our variable m. Another information that we're given is the coordinates of r and s, together with the radius of our circle. It is said to be 17 units. So we can go ahead and try setting up an equation for our circle in the form x minus a squared plus y minus b squared being equals to r squared. So we're going to have x minus the x value of our center, which is 2. So we have x minus 2 squared plus y minus the y value at the center of our circle, that is m. We square that, and this is equals to the radius squared. The radius is 17 units, so we're going to have 17 units squared. As you can see, if we substitute a point on our circle, then we're going to easily find the value of m, because we're going to have a value of x and its corresponding y value. The only variable that we're going to have is m. So we can either substitute the coordinates of r or the coordinates of s and get the value of m. The coordinates of r, minus 13 and 5. If we go ahead and substitute that, we're going to have minus 13 minus 2 squared plus 5 minus m squared being equals to 17 squared. Minus 13 minus 2, that is minus 15 squared, plus 5 minus m squared. 5 times 5 is 25. 5 multiplied by minus m is minus 5m. You multiply that by 2, you get minus 10m. And then minus m multiplied by minus m, that is plus m squared. This is all equals to 17 squared. So we're going to have m squared minus 10m plus 25 plus minus 15 squared minus 17 squared being equals to 0. So we're going to have m squared minus 10m minus 39 being equals to 0. So we're factorizing this equation here. The question to ask ourselves, which two numbers do we multiply and get minus 39? But when we add them, we get minus 10. That is minus 13 and plus 3. So we're going to have m minus 13 multiplied by m plus 3 being equals to 0. M is equals to 13 or m is equals to minus 3. Let's look at m and its position and see what makes sense. M is the y coordinate in the first, second, third, fourth. In the fourth quadrant, y is negative. So the answer we're going to take is that m is equals to minus 3. It is not equals to 13. Right, so that is the value of m. The question that follows, we're supposed to determine the equation of the circle in the form x minus a squared plus y minus b squared is equals to r squared. We have all we need to set up this equation. We're going to have x minus 2 squared plus y minus 3. So it is just y plus 3 squared being equals to r squared. We know that our radius is 17 units. So we're going to have 17 squared. What is 17 squared? That is 289. So instead of writing 17 squared, we can write 289. So let me just do that instead. We have 289. And this is the equation of our circle. Let's go to 4.1.2. Determine the gradients of NR. So let's go ahead and look at NR. We have the coordinates of R and we have the coordinates of N. So it will be pretty much straightforward. So NR will be equals to, let's say, y of R minus y of N divided by x of R minus x of N. So what is y of R? That is 5. And y of N is the value of M, which is minus 3. Everything divided by x of R, which is minus 13, minus x of N, which is 2. NR is equals to 8 divided by minus 15. And just like that, we have the gradient of NR. Let's go to the question that follows. B. We're supposed to find the gradient of NS. This is too good to be true. How can we find the gradient of NR? And then after doing that, we find in the gradient of NS. Something seems fishy, but we're going to find out soon. NS, do we have the coordinates of S? Yes, we do. Here they are. They're given to us in our problem statement. So we're going to have y of S minus y of N divided by x of S minus x of N. What is y of S? That is minus 11 minus y of N, which is minus 3. Everything divided by x of S. X of S is minus 13 minus x of N, which is 2. On the numerator, we have minus 8, and on the denominator, we have minus 15. So this is just equals to 8 divided by 15. We have the gradients of NR and that of NS. The question that follows, 4.1.3. The tangents at S and R intersect at P. Calculate the size of P2. 6 marks. So maybe we're calculating the gradients of NR and NS so that we can answer 4.1.3. Because without us calculating the gradients of NR and NS previously, 4.1.3 probably has a 9 or 10 marks. So it makes sense that we had to calculate the gradients of NR and NS so that we can use them to then find the size of angle P2. Let's see how we can actually do that. So P2 is this angle here. Let's just highlight it so that it is clear to see. We have the gradients of NS and that of NR. PS and PR are tangents, and the tangents are perpendicular to the radius. So if we have the gradients of NR and NS, we have the gradients of PS and PR. If we have the gradient of PR, we can find the inclination. Let's call that inclination K. So we have this angle here. Well, not of yet, but we know fully well that it is quite easy to find the size of that angle. And then we have the gradient of line PS. So it will also be easy to find the size of this angle, the inclination. Let's call it Q. But if the inclination of PR is K, then this angle right here should also be equals to K, a vertically opposite angle. So we can say that Q is equals to K plus P1. An exterior angle of a triangle is equals to the sum of the interior opposite. So if we find Q, which we have enough information to do, and we find K, then we can find P1. And if we find P1, we're going to use the sum of angles on a straight line to find P2. So let's start with K. Let's see how we can find the size of angle K. We know fully well that the gradient of NR, what is the gradient of NR again? It is minus 8 divided by 15. We want to use it to find the gradient of PR. So the gradient of PR multiplied by the gradient of NR should give you NR should give you -1. Why are we saying that? The radius is always perpendicular to the tangent. So now we can say that the gradient of PR is equals to -1 divided by -8 divided by 15. This is just equals to -1 multiplied by 15 divided by -8. So the gradient of PR is 15 divided by 8. So let's go ahead and find the value of K, the inclination of PR. So we can say that tan K is equals to the gradient. So our angle K is equals to tan inverse of 15 divided by 8. And if you do that, you should get 61.93 degrees as the size of angle K. So now we have angle K. Let's go ahead and find the size of angle P. So the gradient of PS, will be equals to -1 divided by the gradient of NS. The gradient of NS is 8 divided by 15. So the gradient of PS will be -15 divided by 8. So angle Q will be equals to tan inverse of -15 divided by 8. This is -61.93. If we have a negative, we can just simply add 180 to find the angle of inclination. We're going to get 118.07 degrees. So now we have Q. Let's not forget, our point is so that we can say Q is equals to K plus P1. Q is 118.07. And what is the value of K? We just calculated it above. That is 61.93. So 61.93 plus P1. P1 should be equals to 118.07 minus 61.93. If you put that in your calculator, you're going to get 56.14 degrees. But then that's not it. We're not looking for P1. We're looking for P2. So P2 will be equals to 180 minus 56.14, and that is 123.86 degrees. Yeah, it is a long and painful exercise, but we have to do what we have to do. So that is 4.1.3. Let's go ahead and do 4.1.4. 4.1.4. Circle N is reflected about the x-axis and then translated 2 units upwards to obtain circle M. Determine the equation of circle M in the form x minus c squared plus y minus d squared is equals to r squared. Okay, we have a few translations here. Let's go ahead and look at the first one. So reflection about the x-axis. You just put a negative sign on the y value. So the coordinates of n were 2 and -3. If we reflect about the x-axis, we're going to get 2 and +3, because minus multiplied by -3 should be +3. So that is our reflection. And now we need our translation, 2 units upwards. So 2 units upwards. How will that affect our equation? Now we have 2 and 3. We need to move 2 units upwards. From +3, if we move 2 units upwards, then we're going to have 2 and 5. If we moved 2 units upwards before the reflection about the x-axis, we were going to have 2 minus 1. But we're reflecting about the x-axis first before our translation. Hence, we have 2 and 5 as the coordinates of our center. Now let's just conclude by setting up our equation. We have x minus 2 squared plus y minus 5 squared being equals to r squared. Nothing was said about the radius, so I'm assuming it's still the same, 289. 4.1.4. Let's move to 4.2. An infinite number of circles, each touching the next, are drawn between O and C. Let's just go ahead and highlight that. We have O at our center and C there. And then the centers of all the circles lie on the negative x-axis. The radius of the largest circle centered at A is 4 units. And the radius of each circle thereafter is halved. B is a point on the largest circle. 4.2.1 show that OC is equals to 16 units. We're supposed to show that OC is equals to 16 units. The first circle has a radius of 4 and a diameter of 8. And then the next circle will have a radius of 2 and a diameter of 4. And then we're going to have plus 2, plus 1, so on and so on until we reach infinity. So what I'm realizing here is that our first term is 8 and our ratio is 1 divided by 2. Because the radiuses of our circle are getting halved. So if we have infinity circles between O and C, then we can simply say that the sum to infinity is equals to A divided by 1 minus R. A being the diameter of the first circle, that is 8. And we divide that by 1 minus the ratio. The radiuses are getting halved. So we have 1 divided by 2. And this is equals to 16. So indeed, the value of OC is 16 units. Let's move ahead and do 4.2.2. If BC is a tangent to circle A at B, write down the size of angle ABC, providing a reason for your answer. If BC, let's just join BC so that we can have a bit of clarity. So yeah, we need BC. Let's go ahead and just join those 2 points. BC is a tangent, AB is a radius. We know that the radius is perpendicular to the tangent. So that is to say that the size of angle ABC is 90 degrees because the tangent is perpendicular the radius. 4.2.3, hence determine tan of angle C. So we're looking for tan of this angle right here. Well, now we have a right angle triangle. This angle here is 90. So AC is our hypotenuse. Tan of theta is equals to the opposite divided by the adjacent. So the opposite is AB. So what is AB? AB is equals to 4 units. That is our radius. And what about AC? AC is equals to OC minus OA, right? OC is 16 units, OA is 4 units. So AC is equals to 12 units. AB is our opposite, AC is our hypotenuse. We need to find BC, our adjacent. Let's go ahead and do that and see what we're going to have. We can say that AC squared is equals to AB squared plus BC squared. AC, that will be 12 squared, being equals to AB 4 squared plus BC squared. So it should be easy to see that BC is equals to the square root of 144 minus 16. This is equals to 8 square root of 2. So now we can say that tan of angle C is equals to the opposite. The opposite is 4 units divided by the adjacent, which is 8 square root of 2. We can further simplify that, but let's just leave it like that. And 4.2.4, the last question, we're looking for the equation of BC. Angle C is the inclination of line BC. So this is the gradient of the line BC. So now we can say that y is equals to mx plus c, but we know the value of m. It is 4 divided by 8 square root of 2x plus c. We just need to substitute a point and we have the equation of BC. Which point can we substitute? We can substitute point C, because we know that at C, the x coordinate is minus 16 and the y coordinate is 0. So if we substitute that, we're going to get 0 being equals to 4 divided by 8 square root of 2 multiplied by minus 16 plus C. So C will be equals to 4 square root of 2. And now we can conclude and say that the equation of BC, 4 divided by 8 square root of 2x plus 4 square root of 2. Tan of theta is equals to the opposite divided by the adjacent, where most of the time the opposite is y and the adjacent is x. So in our case here, we're going to have tan of alpha being equals to y divided by x. What is the value of y? Let's look at tan of alpha. We can see that the y value is 4 and the x value is 3. So we're going to have 4 divided by 3 as tan of alpha. Let's move to the equation that follows. 5.1.2. Determine the value of sine of 90 degrees plus alpha. Sine of 90 plus alpha will be equals to cos of alpha. Now we just need to figure out what cos of alpha is equals to. Cos of theta is equals to the adjacent divided by the hypotenuse. The adjacent usually being x and the hypotenuse is obviously r. So we have the value of x. X is equals to 3, but we need the hypotenuse. We can say that r squared is equals to x squared plus y squared. So r will be equals to 3 squared plus 4 squared. R is equals to 5. So now it is easy to see that cos of alpha is equals to the adjacent, which is 3, divided by the hypotenuse, which is 5. That is 5.1.2. Let's look at 5.1.3. Determine the values of m if it is given that 12 plus 13 sine of v is equals to 0. So we're looking for this value here of m on our coordinates r. On our coordinate r, we are using angle v, as we can clearly see. What do we have? We have 12 plus 13 sine of v being equals to 0. So sine of v will be equals to minus 12 divided by 13. But we know that sine is equals to the opposite divided by the hypotenuse. The opposite is usually y, and the hypotenuse is r, obviously. From our coordinate r, we have the y value, which is minus 12, and we have the hypotenuse, which is 13. We are looking for m. So we can set up our equation in the following way. R squared is equals to x squared plus y squared. Like for us, we have r. So we're going to have 13 squared being equals to m squared plus y squared. That is minus 12 squared. We're going to have m squared being equals to 13 squared minus 12 squared. M squared is equals to 25. So it's either m is equals to 5 or m is equals to minus 5. What makes sense between the two values? X is negative in the third quadrant. So m cannot be equals to 5. M is equals to minus 5. So that is 5.1.3. Let's do 5.1.4. Determine the value of cos of alpha plus b. This is a compound angle. We can expand this in the following way. Cos of alpha multiplied by cos of v minus sine of alpha multiplied by sine of v. We know what cos of alpha is equals to from 5.1.2. It is 3 divided by 5 multiplied by cos of v. Cos is x divided by the hypotenuse. X in our case is the value of m if we are looking at angle v. That is minus 5. And the hypotenuse is 13. So we have that there. Minus sine of alpha. Sine is opposite, which is y. What is the value of y at point P? That is 4. Divided by our hypotenuse, which is 5. Multiplied by sine of v. The value of y at r, that is minus 12. Divided by the hypotenuse, which is equals to 13. This is equals to 33 divided by 65. Determine the values of a and b. We have f of x, which is equals to a sine of x. And we have g of x, which is equals to cos bx. So we're looking for the value of a. How can we simply determine the value of a? We can look at the highest point of our graph, f of x, because that is what a determines. It controls that highest value, the amplitude. So here in our graph, it is easy to see that the highest point that f reaches, f of x, is 2. So we can say that a is equals to 2. And now let's look at g of x. We are interested in the value of b. If you look at the graph, if you look at the sketch, the diagram we have, you're going to realize that we have an original cosine graph. This graph, g of x, it is just equals to cos of x. There's no alterations whatsoever. So the value of b in g of x should be equals to 1, because that is just the shape of cos of x. So what are we saying? We're saying that a is equals to 2 and b is equals to 1. That is 6.1. Let's look at 6.2 and 6.2.1. Consider the interval x is an element of 0 to 180. The first question, let's calculate the values of x for which a sine of x minus cos b of x, not cos b of x, but cos bx is equals to 0. We know the values of a and b, so let's go ahead and substitute those. We're going to have 2 sine of x minus cos x being equals to 0. Let's take cos x to the right hand side. If we do that, we're going to have 2 sine of x being equals to cos of x. Well, if we say sine of x divided by cos of x, then we're going to have tan of x. So let's divide both sides by cos of x. If we do that, we're going to have 2 sine of x divided by cos of x being equals to 1. Cos of x divided by cos of x is 1. But instead of having sine of x divided by cos of x, we can write that as tan of x. This is equals to 1. You can see here that we're going somewhere. Tan of x will be equals to 1 divided by 2. So we can say that x is equals to tan inverse of 1 divided by 2. The value of x is 26.57. And just like that, we've answered 6.2.1. Just a bit of algebraic manipulation. 6.2.2. For which values of x will g of x multiplied by the gradient of f of x be greater or equals to 0? Let's go ahead to our sketch and do some sort of constructions. Let's look at g of x first. Where is g of x positive and where is g of x negative? We're gonna highlight where g of x is positive with a green color and where g of x is negative with a red color. So from this point up until x is equals to 90, g of x is positive. And then from 90 to 180, it is negative. Now let's look at f prime of x. F prime of x, That is the gradient. When is the gradient of f of x positive and where is the gradient of f of x negative? The gradient of f of x is positive when the graph is sloping up. The gradient is just the slope, and it is negative when the graph is sloping down. When is our gradient sloping up? From this point up to x is equals to 90, we have a positive slope. And then from x is equals to 90 to x is equals to 180, we have a negative slope. So as you can see, when g of x is positive, f prime of x is also positive. The product of those two graphs will be positive. And when g of x is negative, the gradient of f of x is also negative. Negative multiplied by negative is positive. So it seems like when x is an element of 0 to 180 degrees, our condition is satisfied. G of x multiplied by the gradient of f of x is greater or equals to 0. Let's look at 6.2.3. Quite an interesting one. Determine the values of y for which y is equals to 2 to the power 2 multiplied by f of x minus 1. Let me know in the comments how you think we should approach this question, because the problem I'm having here is that we're looking for the values of y. So I don't know what y is, but I also have f of x and I'm not given one value of x. So how are we gonna navigate that? We don't have any information and we have two variables. Please let me know in the comments. I think I've cracked this topic. Let me tell you why I'm saying that. I know all the exact steps that you need to follow to be able to answer any question. Determine whether your triangle is right angled or not. If it is right angled, then the first thing you should try is to use trig ratio. Sine of theta, cos of theta, and tan of theta. And if trig ratios don't work and it is a right angled triangle, then you can use the theorem of Pythagoras. C squared is equals to b squared plus a squared. This is the first two things you should be looking at. And if it is not a right angled triangle, then we're going to move to the sine rule. This is step number 2 if step number 1 seems to not work. And if the sine rule doesn't work, we're going to use the cosine rule. Right, and if the cosine rule fails, then the area rule is going to work. This is the approach you should be taking. Let's see if it is going to work on this question. Well, we're not seeing. I know it is going to work. Let me show you that it works instead. 7.1, write BF in terms of theta and y. So let's go ahead and look at BF. BF is this side. It's our triangle right angled. Well, it is not. There is no angle which is equals to 90 degrees. So we cannot use trig ratio or theorem of Pythagoras. The second step is using the sine rule. So let's see if we can apply it. We're looking for BF. BF is opposite angle theta. And then we have side AF, which is opposite angle B of size 30 degrees. As you can see, the sine rule is going to work. So in triangle ABF, we have sine of 30 degrees divided by y. You see the angle divided by the side opposite. This is equals to sine of theta divided by BF. Let's cross multiply. We're going to get BF multiplied by sine of 30 degrees being equals to y multiplied by sine of theta. So BF is equals to y multiplied by sine of theta divided by sine of 30. But sine of 30 is special. So BF is going to be equals to y sine of theta divided by a half. This is just equals to 2y sine of theta. Our answer to 7.1. Let's go ahead and look at 7.2. So again, we're looking at our steps. The first step is to determine whether our triangle is right angle or not. DF is a side on triangle DFE. So we're going to use that triangle. So we're going to say that in triangle DEF, it is not the right angled triangle. So we cannot use trig ratios or theorem of Pythagoras. We're looking for DF. DF is opposite angle alpha. And then we have angle F of size 30 degrees, which is opposite X. So the sine rule is going to work again. Sine of 30 divided by X is equals to sine of alpha divided by DF. Let's cross multiply. Sine of 30 is a half. So we're going to have a half multiplied by DF being equals to X sine of alpha. So DF, if we divide by a half on both sides, we're going to have 2x sine of alpha. So there we go. We have the size of angle DF in terms of alpha and x. 7.3. Hence prove that BD squared is equals to 4x squared sine alpha squared plus 4y squared sine theta squared. BD squared. Let's go ahead and look at BD. BD is this side right here. If we look at triangle BDF, you will realize that we have a right angled triangle. So we can use theorem of Pythagoras to find the size of BD. We have BF, we determined it, and we also have DF. So we can say that BD squared is equals to DF squared plus BF squared. BD squared will be equals to DF squared. That is 2x sine of alpha squared plus BF squared. That is 2y sine of theta squared. So BD squared will be equals to 2x squared. That is 4x squared. And then sine of alpha squared plus 2y squared. That will be 4y squared sine of theta squared. So we have proved what we are required to prove. That is 7.3. Let's go ahead and do 7.4. In our equation, we have the variables x and y. So we should be using a triangle that have those variables. Let me just erase all this for the sake of clarity. We have BD squared. We just determined it in the equation above. And BC is 3x and CD is 4x. Our triangle is right angled. So we can go ahead and try using the theorem of Pythagoras. CD is clearly our hypotenuse. So we can say that 4x squared is equals to 3x squared plus BD squared. But we know what BD squared is equals to. But what about 4x squared? 4x squared is just 16x squared being equals to 3x squared, that is 9x squared, plus BD squared. BD squared is 4x squared sine of alpha squared plus 4y squared sine of theta squared. Let's take all the terms with x to the left-hand side. We have 9x squared and 4x squared sine of alpha squared. If we take that on the left-hand side, we're going to have 16x squared minus 9x squared minus 4x squared sine of alpha squared being equals to 4y squared sine of theta squared. So what is 16x squared minus 9x squared? That is 7x squared. And then minus 4x squared sine of alpha squared. This is all equals to 4y squared sine of theta squared. So on the left hand side, we can take x squared as a common factor. If we do that, we're going to have x squared multiplied by 7 minus 4 sine of alpha squared. This is all equals to 4y squared sine squared of theta. We can divide both sides by 7 minus 4 sine of alpha squared. If we do that, we're going to have x squared being equals to 4y squared sine of theta squared, everything divided by 7 minus 4 sine of alpha squared. Taking square roots on both sides, we're going to get x being equals to the square root of 4y squared sine theta squared divided by 7 minus 4 sine of alpha squared. We will find keywords in our question statement, and we're going to use those keywords to answer all our questions. So in the diagram, ABC is a tangent. So tangent is a keyword. We know that we have the tan chord theorem. So tangent is a word we are interested in. So I have tangent. And then it goes on to say that F, E, and D are points on the circle. EF is equals to BF. Let's write that down. EF is equals to BF. I think that's all. Let's see if we can use these keywords to answer our questions. 8.1. Determine with reasons the size of the following angles. We have angle E1. Angle E1 is right here. Let's see if we can use the first keyword to determine the size of angle E1. The first keyword is tangent. So I'm thinking tan chord theorem. Well, my tangent is ABC. And between ABC and line FB, that chord, there's an angle of 32 degrees. That angle should be equal to the angle subtended by that chord at the circumference of the circle. So now we can say that E1 is equal to angle ABF. Why are we saying that? This is the tan chord theorem. Angle F given reasons. So let's go ahead and highlight angle F. We have said that angle E1 is equal to 32 degrees. But I want you to realize something. Our second keyword, EF is equal to BF. Angles opposite equal sides. So E1 is equal to B1 because those two angles are opposite equal sides. So they should be equals to each other. So if E1 is 32 and B1 is 32, it will be easy to find the size of angle F using the sum of angles on a triangle. So we're going to have 2E1 plus angle F being equals to 180 degrees. This is the sum of angles on a triangle. So angle F is equals to 180 minus 2 multiplied by 32. 2 multiplied by 32, that is 64. So we have 180 minus 64, which is 116 degrees. So that is the size of angle F. And then after angle F, we are now looking for angle D. Angle D is right here, far away from all the other angles. Looking at E, F, B, D, that is a cyclic quadrilateral. F plus D, angle F plus angle D should be equals to 180 degrees. This is because the opposite angles of a cyclic quad are supplementary. So D is 180 minus 116. We know that this is equals to 64 degrees. So we have the size of angle D. Let's see what else we need to find. We need to find the size of angle O1. So O1, it is at the center of the circle. Well, without thinking too much, the angle at the center of the circle is twice the angle or the same arc that is on the circumference of the circle. So that is our angle D. So what are we saying? We're saying that O1 is equals to 2 times angle D. Angle at center is 2 times the angle at the circumference. They have to be in the same arc or subtended by the same chord. So O1 is 2 multiplied by 64, 120, and 128. So O1 is 128 degrees. The last question, we are looking for E2. So right, let's go ahead and see what we have for E2. Well, at this point, we know fully well that O1 is equals to 128, but OB is a radius, and OE is also a radius. So E2 is equals to B2 because angles opposite equal size. 2E2 plus O1 is equals to 180 degrees. So 2E2 will be equals to 180 minus 128. Everything we dividing by 2 on both sides. So let's just go ahead and show that. If we do that, then E2 is equals to 26 degrees. If angle ABR is equals to x, write down 3 other angles in the diagram which are also equal to x, providing reasons. So let's go ahead and read our question statement and extract a few keywords that we're going to use to answer all the questions that follow. So the question says that in the diagram, RS is a tangent. So there goes our first keyword, tangent. We know that with regards to a tangent, we have the tan chord theorem. And on top of that, the tangent is always perpendicular to the radius. Let's carry on. SAB is a line that passes through the circle. And RT is parallel SAB. RT is parallel SAB. There's a few things we know about parallel lines. Alternating angles, cointerior, so on and so on. The other keyword that we have is that MT is equals to AB. That can come in handy because equal cos subtend equal angles at the circumference of the circle. So let's go ahead and answer our questions. 9.2.1. We want 3 other angles that are equals to x while giving reasons. So let's go ahead and try our first keyword, which is the tangent. Well, angle x is subtended by line RA. Well, let me not say line, but say chord. It is subtended by chord RA. But then, between chord RA and our tangent RS, there's an angle R1. We have the tan chord theorem right there. So we can say that R1 is equals to X because of the tan chord theorem. So we have used our first keyword to find an angle that is equals to X. Let's see if we can use the second keyword to find an angle that is equals to X. So the second keyword, RT, is parallel SAB. So where is RT? Let's go ahead and look for that. We have RT right here and is parallel SAB. So this line. If these two lines are parallel, then angle X should be equals to angle R3, alternating angles. So R3 is equals to X because they are alternating angles. So we have used the first 2 keywords. Let's see if we can use the third one. Well, neither MT or AB is subtending angle X. So I don't think we can use that. Let's go to our diagram now and see what we can come up with. Well, you should realize that the chord RA, it's subtending X. But at the same time, it is subtending M1. So X and M1 should be equal to each other. So now we can say that M1 is equals to X. And why are we saying that? Angles in the same segment. They are angles in the same segment. So there we go. We have 3 angles that are equals to X. So let's go ahead and answer the following question. But before we do that, let's put X in place of R1, R3, and M1 because we are saying that those angles are equals to X. It will help us when we answer other questions. So here at R1, we have x. At R3, we have x. And at M1, we have x. Right, now we can carry on and answer our questions. 9.2.2. If angle ARB is equals to y, this angle right here, provide the reason why MRT is equals to 1. Why angle MRT is equals to 1. Which angle is MRT? This angle here. Apparently, they are equals to each other. What I'm realizing is that angle R2, or our angle Y, is subtended by AB, and angle R4 is subtended by MT. But we know that MT and AB are equals to each other. That is our third keyword. And equal chords subtend equal angles at the circumference of the circle. So that is the reason you're supposed to give. Equal chords will subtend equal angles at the circumference of the circle. So instead of having R4, let's replace it with Y, because now we know that it is actually equals to Y. So we have Y here. Here we also have Y, and here we have X. 9.2.3. Write A1 in terms of X and Y. What is A1? A1 is this angle here. It should be easy to see that A1 should be equals to X plus Y. An exterior angle of a triangle is equals to the sum of the opposite interior. Right, angle A1 is an exterior angle of triangle ABR. It is an exterior angle of the triangle. So it is equals to X plus Y. Yeah, that one is quite easy to see. Oh, this was A, and now we at B. B is saying that we must write N1 in terms of X and Y. N1, we have the same reasons as A1. It is an exterior angle of a triangle. In this case, it is an exterior angle of triangle NMR. So N1 is also equals to X plus Y. That is 9.2.3. And 9.2.4, we're supposed to prove that triangle SAR is similar to triangle KNR. Let me just go ahead and highlight those triangles first before we carry on. There we go. These triangles are named such that S in triangle SAR should be equals to K in triangle KNR. And then A and N should be equals to each other. The same with R and R. That is a huge tip. If you're not aware of that, it is very difficult to answer these questions. Let's look at angle S and angle K. We have angle S right here, and here we have angle K. But then previously, we have not talked about angle K and angle S. So it will be quite difficult for us to prove that they are equals to each other. Compared to angle A and N, which we've talked about, and angle R. Let's see if we can use angle A and N and angle R and R. In triangle ARS, angle A1, we know that angle A1 is equals to X plus Y. And then in triangle KNR, we know that angle N1 is also equals to X plus Y. That's what we figured out in 9.2.3. So we can say that A1 is equals to N1 because they are both equals to X plus Y. Now we just need another pair of angles that are equals to each other in the two triangles. And we have proved that they are similar. Let's go and look at angle R and angle R. In triangle SAR, we have R1, which is equals to X. So we know that R1 is equals to X. And in triangle NKR, we have R3, which is also equals to X. So we can say that R1 is equals to R3 because they are both equals to X. And if that is the case, then we have proved that the two triangles are similar. We can just go ahead and say that angle K2 should be equals to angle S. because of the sum of angles on a triangle. Triangle SAR is indeed similar to triangle KNR. Angle, angle, angle. All three angles are equal to each other in those two triangles. The last question, 9.2.5. Let's hear the stories. Prove with reasons that SAKR is a cyclic quadrilateral. SAKR. So let's just go ahead and look at SAKR. SAKR. K2 is equal to angle S, as you can see right here. This is because triangle SAR is similar to triangle KNR. So SAKR will be a cyclic quad because the exterior angle is equal to the interior opposite. Prove that P1 is equal to A1 plus B1. That is the first question. 10.1. If you're wondering why I didn't include the question statement, it is because there is absolutely no keyword. But we can come up with a few. You should be able to realize that PQCB is a cyclic quad on the smaller circle, and BRAC is a cyclic quad on the bigger circle. So let's go ahead and see how we can get to P1 being equals to A1 plus B1. But let's stick to the basics here. We have P1 as an exterior angle of triangle ARP. So we can say that P1 is equals to A1 plus R2 because P1 is an exterior angle of that triangle. It is equal to the sum of the two opposite interior. But we can also say that P1 is equal to angle C. Why are we saying that P1 is equal to angle C? An exterior angle of a cyclic quad is equal to the opposite interior. So P1 is equal to angle C. So we need to prove that A1 plus B1 is equal to A1 plus R2. Basically prove that B1 is equal to R2. Or we need to prove that A1 plus B1 is equal to C. We need to prove one between these two. If we do that, then P1 is equal to A1 plus B1. So let's go ahead and look at the first option, proving that B1 is equal to R2. If B1 is equal to R2, then P1 is equal to A1 plus R2. So let's go ahead and look at that. We have B1 here, as I've indicated, and where is R2? We have R2 right here. Right, if you take some time and try figuring out if you can see that R2 is equal to B1, you're going to realize that it is a quite difficult exercise. I couldn't prove that. That is why I moved to option 2. A1 plus B1 is equal to angle C. Let's see how that comes about. So in triangle ARB, take your attention to triangle ARB. You will realize that A1 plus B1 plus angle ARB is equal to 180 degrees. This is just the sum of angles on a triangle. Then angle ARB will be equal to 180 minus A1 minus B1. That is the size of angle ARB. It is 180 minus A1 minus B1. But this angle ARB, this entire angle ARB, if we add it to angle C, we must get 180 degrees. The opposite angles of a cyclic quad are supplementary. So angle ARB is equal to 180 degrees minus angle C. Clearly, if those two statements are true, then A1 plus B1 should be equals to angle C. So A1 plus B1, they're equals to angle C. So we can conclude and say that P1 is equals to angle A1 plus angle B1. Why are we saying that? They both equals to angle C. That is 10.1. Quite a tricky question, but it is doable if you give yourself enough time. Let's move to 10.2. We're supposed to prove that AR squared is equals to AP multiplied by AB. Well, usually when we have a question like this, we need to prove similarity. Well, we have side AR, AP, and AB. Let's see if we can find two triangles that have only those sides. Right, let's just erase all this so we can have a bit of clarity. We have side AR right here, and we have AP. Wait, side AP? Side AP is right here. And then if we join R and P, we have a triangle. And then another side we have is AB. So it seems like we are also interested in this triangle. We have to state that we're interested in triangle ARP and triangle ABR. Right, so in those two triangles, angle A1 is equals to angle A1. Why are we saying that? It is just a common angle. It's shared by the two triangles. In 10.1, this is how we started. We said that P1 is equals to A1 plus R2. This was because P1, it is an exterior angle of the triangle ARP, right? But then we ended up concluding that P1 is equals to A1 plus B1. We were actually asked to prove that, and we were able to prove it at the end. If P1 is equals to A1 plus R2 and P1 is equals to A1 plus B1, then that tells us that R2 is equals to B1. We can clearly see that R2 is equals to B1. R2 is equals to B1, and angle A is common. Now we can say that angle P4 is equals to angle R2 plus R1. If those pairs of angles are equals to each other, then P4 should be equals to R2 plus R1 because of the sum of angles on a triangle. And just like that, we can conclude and say that triangle ARP is similar to triangle ABR. Angle, angle, angle. AR divided by AB is equals to AP divided by AR. This is because triangle ARP is similar to triangle ABR. If we cross multiply, you're going to get AR squared being equals to AB multiplied by AP.